refraction through prism. Okay. So, most of the cases, number of questions we are seeing from this refraction through prism is when you are taking a monochromatic light and a polychromatic light. See, more questions on monochromatic light. Mono means single and chromatic means color. So, when you are using the monochromatic light when passed through our glass prism, then how the light ray refracts, or when you are taking about a polychromatic light when passed through our glass prism, in that case how the refraction takes place. Both cases we have. Okay. Monochromatic light and polychromatic light, that is. Okay. Monochromatic, actually as it is having more number of colors, means polychromatic means the wavelength is more in number we have. Whereas in case of this monochromatic you are taking, then we are having only single colored wavelength only possible here. So, the wavelength of the light, it is single we have in case of monochromatic light. Then we already know that when you are taking any of the glass prism, if you are taking a monochromatic light, which is the first case, monochromatic light if you are taking, now when the light ray is coming from air, when enter into the glass medium, which is our glass prism, which is acting like a denser medium, that is, then what happens there is the light ray is refracting here towards the normal, because the light ray is coming from rarer medium to denser medium, that is. So, the light ray bends towards the normal in that case. So, that here after refraction, now the light ray is going to enter onto the another surface here. Okay. Then after that again it is passing back to the air. So, it started from air coming into the glass, and after that again it is going back into the air here. Then when it is going back into the air, then what happened there is now the light ray bends away from the normal, of which we already seen that is going down like this. Okay. Now, this is the actual case when you are taking a monochromatic light when it is passed through a glass prism here. Okay, of which the light ray started from air passing into the glass, and after that from glass back into the air here. Okay, like this. Now, during this refraction case, what happens there is when you are taking the light ray which is projected upwards here, making in some angle with the refracting surface. If you observe there, the light ray is now deviating downwards here. So, which means this angle we call that as angle of incidence, and this angle of which the light ray is coming out from that glass prism, that angle we call that as angle of emergence, that is, and the angle between the two refracting surfaces, this we call that as angle of the prism A, and another angle we have angle of deviation, how much is the light ray is deviated. Actually, we can find that by extending the incident ray and the emergent ray, and they both are meeting at a point, that point only we call that as angle of deviation. So, more number of questions are coming on using these angles and their relations here. Okay. But remember, when you are taking angle of incidence and angle of deviation here, when you are increasing the gradually the angle of incidence, the angle of deviation gradually decreases. At one particular stage, that angle of incidence and angle of deviation becomes a minimum here. Okay. Now, the relation between these four angles is angle of incidence plus angle of emergence is equal to angle of the prism plus angle of deviation. This is the relation between these four angles. I plus E is equal to A plus D, where I is the angle of incidence, angle between the incident ray and the normal, and E means angle of emergence, which is angle between the emergent ray and the normal, and A means the angle of the prism, and D means angle of deviation here. Okay. So, I plus E is equal to A plus D, that is, here when you are taking the angle of the prism, most of the cases we are using equilateral glass prisms, that is, when given if it is a equilateral glass prism, then we have to take the angle of the prism as 60 degrees, that is taken as angle of prism is equal to 60 degrees, that is. Okay. Now, the main important thing here is when we will have the minimum deviation. See, this minimum deviation condition, it is formed when the light ray here, if you are incidenting any of the light ray onto the surface of the glass prism here, refracting surface, after refraction, first refraction is over, the light ray when it is inside the glass, if this light ray and the base of the glass prism, when these two are parallel to each other, in those cases we are having the prism angle, that angle of deviation becomes a minimum, that is. So, which is, see that again, when you are taking the refracted ray when enter into the glass here during the refraction through glass prism, the first refracted ray and the base of the glass prism, these two get parallel to each other. In that case only we are having the minimum deviation is possible. Let us say for example, if the prism we are taking is ABC, let us suppose here we are taking the points that incident ray, let it be that is PQ, and let us suppose the emergent ray, it is of R and S if you are taking. Then when we will have the minimum deviation is deviation which is minimum is equal to here, when you are taking this Q and E, B and C, when these two are parallel to each other, QE and BC, when these two are parallel to each other, in those cases the angle of deviation becomes minimum. But remember, when you are having a minimum angle is present, we can find the refractive index of the glass prism, that is. And we know already that to find the refractive index of glass prism, the formula is mu is equal to sine of A plus dm by 2, whereas dm represents the minimum angle by sine A by 2, where A represents, that is nothing but the angle of the prism, that is sine of A plus dm by 2 by sine A by 2, that is. So, most of the cases the questions coming mainly on monochromatic light refraction is mainly on two. One is about the relation between the angles, which is I plus E is equal to A plus D. And the next important question they are asking about when we will have the minimum deviation. Minimum deviation when we are getting is, when you are taking the minimum deviation, the refracted ray and the base of the glass prism, when these two are parallel to each other, in those cases we are having the angle of deviation is minimum. Once you get the angle of deviation minimum there, then we can find the refractive index of glass prism as mu is equal to sine of A plus dm by 2 by sine A by 2. This is the refractive index of the material of the prism we are using, or refractive index of the glass material we are using, which is mu is equal to sine of A plus dm by 2 by sine A by 2. Okay. So, these type of questions they will ask in our exam based on the angles and based on the refractive index, that is. Okay. And another important thing, if you observe here, if you are having the angle of deviation is minimum, then we also having the condition that angle of incidence and angle of emergence, these two are becoming equal here, these two are becoming equal. So, means when minimum deviation case QE not only parallel to BC, here angle of incidence is equal to angle of emergence also, like this. Okay. And if it is of refractive index, this is the case. For general cases, I plus E is equal to A plus D. Okay. If they want to ask an MCQ, their multiple choice question on this one, they will ask you like this. On showing the diagram of which case here, if you want to get the minimum deviation, what is the condition required? The condition required, they may give the options depending on the angle of incidence there, or depending on the lines, the refracted light ray here. If the angles are given, then in those cases angles they have to be equal, I plus E, I is equal to E we have to use. And in case of, if they are giving about the light rays, the light ray which is passing inside the glass prism, that should be parallel to the base of the glass prism here. So, these two conditions we have to apply when you are taking the angle of deviation to be minimum. Now, if you see any of the numericals depending on angles and their relations is, let us say for example, they will ask a question like this. If you are having the angle of incidence, means when an incident light ray strike the refracting surface of the glass prism at an angle, let us say for example 30 degrees, that is. Okay. Now, the question is, if you want to get the angle of deviation to be minimum, angle of deviation to be minimum, then what about the angle of the emergent you have to take, or what is this angle of minimum deviation we have to find here. Okay. We have to find what is the angle of emergence and what is this minimum angle is, and if you are using a glass prism which is equilateral glass prism which is 60 degrees, that is. Okay. Now, the question is, if you are taking a equilateral glass prism having the angle of the prism as 60 degrees there, and we are taking that angle of incidence, it is of 30 degrees is given, so that we want to get a minimum deviation, then what about the angle of emergence and what about the angle of deviation, that we have to find here. As the angle of incidence is given, and if you are taking about angle of minimum deviation here, then we know that angle of incidence is equal to angle of emergence, that is only for the case of minimum deviation, that is. So, as angle of incidence is equal to angle of emergence, then it is equal to 30 degrees, that is. Then angle of emergence we got, which is 30 degrees, that is. Then when come to the case of this angle of deviation here, we know the relation that angle I plus angle E is equal to angle A plus angle D, that is. Okay. Here angle of incidence is equal to, we got 30 degrees is given there, and angle of emergence is also 30 degrees, that is, and we have angle of the prism which is of 60 degrees, that is, plus angle of deviation we have. Then when you are taking that angle of prism here, 30 plus 30, I plus E, which is 60 degrees, is equal to 60 plus D, that is, then angle of deviation becomes 0. This is the minimum angle we have when you are taking, if the light ray incident at an angle 30 degrees there with the surface. So, that to get the minimum deviation here, so that here we are taking angle of incidence equal to angle of emergence. If we use that formula, finally we got that angle of deviation is becoming minimum, that is, which is 0 degrees, that is. Okay. Then in the same way, if they want to ask for different angles here other than the minimum deviation, again we have to use the formula I plus E is equal to A plus D, we have to use there, which is the relation between the angles. For example, for the same question, if they ask like this, if angle of incidence is 30 degrees and angle of deviation is not minimum, we have to find how much is that angle is. And given that angle of emergent, it is about, let us say given it is around 70 degrees, then we have to find what is the deviation angle, that is. When you are taking the angle of incidence as 30 degrees and angle of deviation we have to find here with the angle of emergence 70 degrees and angle of the prism is 60 degrees, that is, then we can write as angle of incidence plus angle of emergence is equal to angle of the prism plus angle of deviation, that is, angle of incidence it is of 30 degrees is there, plus angle of emergence which is given 70 degrees is equal to angle of the prism which is 60 degrees plus angle of deviation we are finding, for which 30 plus 70 which is of 100 minus 60 degrees is equal to D here, then angle of deviation becomes 40 degrees. Like this, we can find, if you know the angle of the incidence and angle of emergence, we can find the angle of deviation for the given equilateral glass prism. Like these type of numericals, they will ask about the relation between the angles. Here given one diagram question that for the given prism, find the refractive index. But actually given, if you observe there, for the given prism, here it is given that the angle between the prism, it is of 60 degrees angle of the prism, angle A which is 60 degrees, and angle of incidence given which is of 60 degrees, and angle of emergence also given, that is of 60 degrees, that is. And we know that if you are having the angle of incidence is equal to angle of emergence there, so that in these cases the angle of deviation becomes a minimum, that is. So, which means as I is equal to E here, then we can find angle of deviation by using I plus E is equal to A plus D, that is, where that deviation angle becomes a minimum in this case. Then angle of incidence is 60, angle of emergence 60, and angle of the prism is 60 here, plus angle of minimum deviation we are finding. So that the angle of minimum deviation also becomes 60 degrees. Now, once you got the angle of minimum deviation, actually here in the given problem, it is given that we have to find the refractive index of the glass prism. Whereas, if you want to find the refractive index of the glass prism here, sine of A plus dm by 2 by sine A by 2 is the formula we have to use. As we know that sine of angle of prism which is 60, angle of deviation we got 60 by 2 by sine of a by 2, where angle of the prism is 60 by 2, that is. Then it becomes mu is equal to sine of 60 plus 60, which is 120 by 2 by sine 60 by 2, which is 30 degrees, that is. Then refractive index mu is equal to, from this you can write sine 60 by sine 30 degrees, that is. Whereas if you know the values of the sine here, which is sine 60, which is equal to root 3 by 2, whereas sine 30 value, it is around 1 by 2, that is. The 2 get cancelled. Finally, we got the refractive index of the glass prism is root 3, that is. So, like this, if you know the angle of incidence and angle of emergence to be both are of same, so that is as it is the condition for the minimum deviation here, we can find by using the angle of the prism, we can find the refractive index of the glass prism, which is mu is equal to sine of a plus dm by 2 by sine a by 2, that is. Okay. From this formula, actually here it is given that is of 60 degrees and 60 degrees if it is the angle. Then we got the angle of deviation is also 60 degrees, which is the special case of which all the 3 angles, all the 4 angles are becoming 60, 60 and 60 here. And not only that, if you take the refractive index here, then mu is equal to sine of 60 plus 60 by 2 by sine 60 by 2. Then we got finally the refractive index mu value, that is equal to root 3, which is 1.732, that is. Like this, depending on the given problem, once if you know the angle between them, we can find directly the refractive index of the glass prism and also the relation between the angles. So, these type of numericals they are asking on refraction through glass prism when you are taking a monochromatic light, that is. Another important one you have to see in this refractive index formula, mu is equal to sine of a plus dm by 2 by sine a by 2 is, when you are taking the refractive index for different materials, on increasing that refractive index material there, the deviation angle also gradually increases here. Okay, which means depending on the refractive index value for the case of glass, for the case of water, for different cases, if you are using any of the denser medium, that refractive index mu, it is directly proportional to the deviation angle here. More and more refractive index we have, then more and more deviation angle we have. So, this is very important one to see. Refractive index is directly proportional to angle of deviation, that is. More and more refractive index, more and more angle of deviation we have. So, if the light ray is getting deviating more, which means that the light ray when passed inside that material here having more refractive index, that is, which means that is of more denser medium. For example, in the exam if they ask, if we are given 3 different mediums like glass, like water and another oil, of the 3 in which case we are having more deviation is present, means we have to take in case of glass which is having more refractive index value. Like that we are having, depending on the refractive index of the material you are taking, the angle of deviation changes for the case of this refracted ray, that is, which is the given monochromatic light. And not only that, if you see the formula here, mu is equal to sine of a plus dm by 2 by sine a by 2, it also depends on the prism, glass prism you are taking, of which here in this case if you are using a equilateral glass prism 60 degrees, then the refractive index of the material you are taking, the deviation angle may change. If you are taking for more angles, for example, if you are using a right angled glass prism, if you are using, then again the angle of deviation changes here. Okay. So, like this angle of deviation, it may change depending on mu value, depending on the angle you are taking for the glass prism, and it is also depending on the angle of incidence we are taking. When you are drawing a graph to this, angle of deviation to the angle of incidence here, taking angle of incidence to the x axis and angle of deviation to the y axis here, then gradually on increasing the angle of incidence more and more, gradually the angle of deviation is decreasing here, means the curve is a falling curve we have like this. On increasing the angle of incidence I1, then gradually the angle of deviation values are decreasing here like this. Now, when come to the case at one particular stage, more and more if you are increasing the angle of incidence, at one particular stage, what happens there is that the angle of deviation becomes minimum. From their point onwards, what happens there is, if you further increase the angle of incidence beyond that, gradually now the angle of deviation also start increasing, that is. So, means if you further increase the angle of incidence more than this critical, more than this deviation angle, more than this minimum deviation if you are taking, then what happens there is here it is goes on increasing, and again it is in reverse curve we are getting that. Gradually it starts increasing upwards there, like this. Okay. So, when you draw a graph between angle of incidence and angle of deviation like this, we are getting a curve like a parabola, that is gradually the angle of deviation is decreasing. At one particular stage where we have angle of incidence is equal to angle of emergence is present, from that point if you further increase the angle of incidence, again in reverse, now the angle of deviation is gradually increasing in that case. Like this we are having different kinds of problems we are getting based on this monochromatic light when passed through the glass prism. They may be asked about the angles here, or you can take about the graph also here. Here one more numerical they give. If the refractive index of the glass prism, which is an equilateral glass prism, is given is √2, then find the minimum deviation and the angle of incidence, that is. So, already now we know that the refractive index of the glass prism is given as √2, that is. And not only that, this is an equilateral glass prism having the refractive index of √2 here. As it is given that mu value is equal to √2 there, and we know that mu is equal to sine of a plus dm by 2 by sine a by 2, that is sine of a plus dm by 2 by sine a by 2, that is. Then as it is mu is equal to √2 here, and we also know that that is given an equilateral glass prism, whereas for the case of equilateral glass prism we are having a 60 degrees is the angle of the prism for them. Then mu is equal to, as it is given, that is of √2 is equal to sine of a plus dm by 2 by sine a by 2, where that a it is equal to 60 degrees, that is. Then if you take √2 is equal to, then here sine of a plus dm, which is 60 plus dm by 2 by sine 60 by 2, which is sine 30, that is. Then if you find the √2 value there again, then √2 is equal to, from this we can write sine 60 plus dm by 2 sine of 60 plus dm by 2 by sine 30 degrees, which is equal to 1 by 2, that is. If you bring that 1 by 2 this side, then it becomes √2 of 1 by 2 is equal to sine of 60 plus dm by 2, that is. Then from this you can get √2 value here 1 by √2, where 1 by √2 in case of sine we are having, that is for sine 45 degrees we have. So, we can write sine 45, which is of 45 degrees is there, that is √2 is equal to 1 by √2 is equal to sine of 60 plus dm by 2, that is. Then 1 by √2 is nothing but equal to, that is of sine inverse 1 by √2, which is 45 is equal to 60 plus dm by 2, that is. Okay. Of which we can get 2 coming this side becomes 90 is equal to 60 plus dm. Then finally we get minimum deviation is equal to 90 minus 60, which is equal to 30 degrees you will get, like this. So that the angle of minimum deviation becomes 90 minus 60, which is equal to 30 degrees we are getting. Okay. As the angle of minimum deviation, if it is 30 degrees is given, now the question they are also asking about find the minimum deviation, of which we got that as 30 degrees, and we also have to find the angle of incidence for the given equilateral glass prism there. So we have to find also the angle of incidence here. To get that, we know the relation that I plus E is equal to A plus D, where I and E both are same, then I plus I is equal to angle of the prism, which is 60, and here we got angle of deviation, which is also equal to 30 degrees, that is. So 60 plus 30, that is. So 2I becomes 60 plus 30, which is 90, then angle of incidence becomes 45 degrees. So finally we got the angle of minimum deviation is around 30 degrees we have, whereas the angle of the incidence it is becoming 45 degrees for the given equilateral glass prism, which is having the refractive index of √2. Like this, once if you know the refractive index of the glass prism, we can find the angle of minimum deviation. We can also find here the angle of incidence. And if the same question, if they are asking for finding the angle of emergence, also we can find, because during the case of minimum deviation here, the angle of incidence and angle of emergence both are equal. So that's why you'll get angle of incidence is equal to angle of emergence, that is. Now we will see, till now we will see for monochromatic light how the refraction of the glass prism takes place. Now we are seeing for the case of refraction of this glass prism by a polychromatic light. Whereas this polychromatic light means we can take the light which is having more than one wavelength, that is polychromatic light. Okay. In case of this polychromatic light, having poly means more, many. Okay, poly means many, and chromatic means color or wavelength lights. Okay, so inside that light we are having more number of colored light rays are present, means many wavelengths we have. Okay, so the best example for this polychromatic light is white light. White light, we already know that it is a combination of 7 different colors, that is. Now, as the polychromatic light when incident on the glass prism, okay, which is a denser medium here, now what happens there is, now the light ray actually it split into number of colors here like this. It shows 7 different colors ranging from violet to red color, that is. Okay, of which here we are having the range from violet color to red color, that is. Okay. Now, this phenomenon of splitting of white light into different colors, that only we call that as dispersion of light, that is, that you call that as dispersion of light. Means when a polychromatic light when passed through any of the refracting medium like glass you can take, like water you can take, any of that. Here we are getting different colors, that light into splitting into different colors. That phenomenon we call that as dispersion. Now the questions coming on the dispersion is, at first, what is the reason for this dispersion phenomenon? Actually here when you are taking this white light, which is a combination of 7 different colors, and each color is having a different wavelength we have. But once they enter into the glass medium, because of due to refraction, as refraction is nothing but when the light ray is going from one medium to another medium, there is a change in the wavelength and change in the velocity of the light takes place. As it is having 7 different colors, that's why what happens there is, once they enter into a different medium like glass here, these light rays are having the different velocities. As because of due to having the change in velocity is different for the different colors, so that what happens there is they are going in different directions, which means all the light rays are splitting from one to another. They are splitting from one to another, that is. That splitting of light when enter from one medium to another medium, that phenomenon only we call that as dispersion. So the main reason for the dispersion here, it is about having more number of wavelengths, and here because of due to that there is a change in velocity we are getting, that change in velocity only causing the splitting of the waves here, splitting of the colors here. That splitting of the colors which are arranged on the screen, that only we call that as a spectrum. As we can see all these 7 colors very easily, that's why it is called as a visible spectrum, that is. Okay. In our visible spectrum, actually here it is ranging from red to violet we have, of which if you observe here in the diagram, the red color is coming at the top there, whereas the violet color it is coming at the bottom here, red color at the top and violet at the bottom. So it is very clear that when you are taking any of the light, any of the white light when passed through a glass prism, that red color light is deviating minimum, whereas the violet color light actually it is deviating maximum here. So that based on this, here taking how much is the deviation appears, we are having number of questions are there on this refraction through glass prism dispersion, that is. Like say for example, we know that as the refractive index is more, then the angle of deviation also we are having maximum is present for that. So means in our given case, the maximum deviation is meant for violet color, maximum it is meant for violet, whereas the minimum deviation, it is meant for the case of red color we have. As the deviation is minimum for the red color and mu and d both are directly proportional to each other, so that the refractive index of the case of violet, it is more maximum we have, and whereas in case of red the deviation is minimum we have. Okay, that is another relation we got. So the refractive index is directly proportional to the deviation of which that deviation is maximum for the violet color and it is minimum for red color. As the deviation is maximum here, the refractive index is also maximum for that violet and it is minimum for the color of red here. Like this, we are having the refractive index and angle of deviation are related. But whereas our refractive index, actually it is also related to the velocities also here. For example, we know that mu is equal to c by v, where mu is equal to refractive index. C means the speed of light in the vacuum there and v means the speed of light in the given medium, that is. So which means if you see that mu is inversely proportional to the velocity of the light here. So means having more and more velocities, more and more refractive index is there, then the velocity of light in the given medium is less. And in the same way, if we are having a lesser refractive index is present, then the velocity of that inside that glass prism, the velocity of that light inside that, it is more we have. So means mu is directly proportional to 1 by v, or mu is inversely proportional to the velocity in that medium we are taking, velocity of light in that medium. And not only that, we know that as v is equal to n lambda, v is equal to n lambda, where frequency remains the same. When you are going from one medium to another medium, always the frequency never change, frequency always remains the same, frequency remains the same. As v is directly proportional to lambda here, then how refractive index and lambda related are, mu is also inversely proportional to the wavelength here. So like this, we can get from the refractive index cases, the velocity is directly proportional to lambda, refractive index is inversely proportional to lambda, and refractive index is inversely proportional to the speed of light there, and refractive index is directly proportional to the angle of deviation we have. So as we are having 7 different colors are there, most of the cases the questions are coming about their speed, about their wavelengths, or about their angle of deviations, that is. So if you take it, arrange a table here for the case of this refractive index values, velocities values, angle of deviation values, and lambda values here. We are having the case maximum and minimum if you are taking. Now the maximum value you are getting for the case of here, mu is directly proportional to d, where that deviation is maximum for the case of violet. So first we have to take the deviation is maximum for the case of violet, okay, and minimum deviation it is meant for red color if you are taking an angle of deviation, and we know that mu is directly proportional to the angle of deviation. So that's why as the violet color is having the maximum deviation here, the refractive index value of this violet color is also more we have, whereas for the case of red color if you are taking, that is having a minimum refractive index in that medium, having mu d value is minimum for that in case of red. Whereas if you are taking about the velocities here, as the refractive index is inversely proportional to the velocity here, that refractive index is maximum for the case of violet. So that's why here for the case of violet we are having maximum velocity is there. For the case of violet, the maximum velocity we have. This is the velocity of light in the given medium. Whereas if you are taking in case of the refractive index, it is actually inversely proportional to the refractive index. Having more refractive index, less velocity. Having more refractive index is there for the case of violet. So that's why here the velocity becomes minimum for the violet here. So minimum for violet, that is. Velocity is minimum for violet. Whereas if you are taking for the case of red color actually we are having very less deviation we have, of which less deviation we have. As the deviation is less for that, so that's why the refractive index is also less. If the refractive index is less for that red, that is why here we are having the velocity is more for the case of red color, that is. So, the refractive index of red color is less, so that the velocity of light, red color light is more in any of the given medium, that is. And next one we are having the wavelength. In case of wavelength, we know that the velocity and the wavelength both are directly proportional to each other. So, that is why here as the violet we are having the case of maximum deviation and red having the maximum velocity, then wavelength is maximum for the red color and it is minimum for the violet color, that is. Like this, if you arrange the refractive index, velocity of light in the given medium and the deviation, and in the case of the wavelength here, we are having the different values of maximum and minimum for that. For the case of violet, it is having the maximum of refractive index and it is having the maximum deviation angle, that is. Whereas, if you are taking for the case of red, red is having the refractive index value minimum and not only that, the deviation angle is also minimum for the red color. Then when come to the case of this velocity and the wavelength, velocity and wavelength as both are directly proportional to each other. Velocity and wavelength, for the case of red color we are having the maximum value, for the case of violet we are having the minimum value is present. Based on that only, most of the cases we are having more number of multiple choice questions are asking. For example, if they give the question like this, if you are taking for the case of different colors, like in case of violet you can take and red you can take maximum and minimum. Other than maximum and minimum, if you are taking, let us suppose given are three colors, green, orange and blue, like this, green, orange and blue, these three colors are given. Of these three, which color we are having deviating more? Of the given, deviating more is which one? And of the colors which is having maximum wavelength, of that we are having which is having maximum velocity, and after that maximum wavelength, and after that maximum refractive index, mu maximum. This you have to find. Actually here if you arrange the order there, if you are taking the Ŵybger order, that is dispersion order, visible spectrum order there, then the order is like this. Down we are having violet is present, after that indigo, after that blue, after that green, yellow, orange and red, like this we have. So, the deviation angle is maximum. In case of here, actually if you arrange that, the one which is having more refractive index, that one will be deviating more here. So, which means the deviation is more when compared after violet and after indigo we are having blue color we have. So, that is why the deviating maximum of the given three colors, it is of blue color, that is. And maximum velocity if you are taking, we know that velocity and refractive index, that deviation both are inversely proportional to each other. So, that is why here the velocity here it is maximum for the case of the last one, which is green color, next more deviation, after that more deviation is there for yellow, that is. So, of the given three, yellow color is having the minimum deviation there. As it is having minimum deviation means the velocity of that orange color light is a maximum we have, which is here it is orange, that is. And come to the case of wavelength. Wavelength actually if you are having more velocity, the wavelength is also more we have. As that velocity is more for the case of orange, so that is why the wavelength is maximum for the case of orange here. After that if you are taking the refractive index value there, which is mu, for the case of refractive index here it is maximum, for the case of violet we have, because we are having the maximum deviation there. But in this case we do not have that violet, after that violet indigo, after that we are having blue is there. So, that is why the maximum refractive index of the given three colors we are having it for the case of blue is there, because deviation angle and refractive index, these two are directly proportional to each other, and velocity of the light you are taking maximum there for orange, that is why the wavelength is also maximum for the case of orange. Like this, depending on the given number of colors, we can estimate which one is deviating more, or which one is having more refractive index, which one is having more velocity, or which one having more wavelength is present. So, depending on that wavelength and the different colors, we are having different deviations and velocities are present. Like this, we are having many number of multiple choice questions they are asking based on different colors. Now, we will see one more question on the wavelengths there. Okay. Here given that the wavelength corresponding to violet, yellow and blue are lambda v, lambda y and lambda b is given there. Now, of which here we are having different options are given. So, that given that first option lambda b, which is the wavelength of the blue color, is greater than lambda y and greater than lambda v, where v is for violet, and case of b given wavelength of the yellow is less than wavelength of this blue color and it is greater than wavelength of the violet color, that is. And option C given lambda b is less than lambda y, which is less than lambda r, that is. And last option D given lambda y is greater than lambda b greater than lambda r, that is. Actually, if you take the order of the colors here, 7 different colors of our visible spectrum, violet, which is the least one, we are having more refractive index and more deviation angle we have. After that indigo, after that blue, after that green, yellow, orange and red. Actually, this is the order of the spectrum we are having: violet, indigo, blue, green, yellow and orange, that is. Now, of the given 4 options, actually if you follow the order here, as it is of a wavelength, we know that wavelength v is directly proportional to the lambda here. Okay. So, wavelength and lambda velocity both are directly proportional to each other. Okay. So, as we are taking the velocity here, that velocity we already know that is inversely proportional to the refractive index, that is. So, having more refractive index, we are having less velocity, having less refractive index, we are having more velocity is present there. So, that is why here we have to take for the case of which one is having a more refractive index, so that it is having less velocity for that. And because this refractive index actually it is inversely proportional, refractive index is directly proportional to deviation angle, that is. So, means having more velocity, less deviation, having more wavelength, less deviation, that is. So, here we can take the velocity deviations there, deviation and wavelength both are inversely proportional to each other. Lambda value inversely proportional to d, that is. Of which all the 3 colors given violet, yellow, blue, violet, yellow and blue color, like this 3 given there. So, of which of all the given 7 cases there spectrum, the least one we are having more deviation, it is for violet color we have. So, means the violet color is having more deviation is there, so that its wavelength is less we have. So, the least one, minimum one, it is about wavelength is for violet color, that is. And after that if you see, of which the deviation for yellow color, it is of a maximum we have. So, means the maximum wavelength is for the case of yellow color, that is, because as the deviation is less, then the wavelength it is taken is more we have. Then in between that only we are having that B is there, which is blue color is given there. So, whereas that blue color we are having after that violet color you have. So, that is why minimum is for the case of violet, maximum for the case of yellow, in between that we are having blue color is there. So, this violet color, yellow color we are having the maximum, and after that blue color is having the minimum, that is. So, that is why based on the given options there, of which that violet color is having the maximum and blue color after that, and after that given about violet color, that is, which is V, that is. Okay. So, that is why here according to the given question there, here in this case option B is correct here, because why here actually having more wavelength, because it is deviating less. And not only that, for the case of violet color, as the deviation is more for that, here we are having the wavelength it is of less we have. Like that we can judge which one is having the more wavelength or which one is having the minimum wavelength, that is. Okay. Not only that, because depending on the wavelengths here or depending on the velocities here, we are having number of applications are there based on the different colors here. For example, as we are having the wavelength is more for the case of red color, that wavelength which is nothing but the distance covered by the wave in the given time there. So, that the distance covered is more for the red color. So, that is why we can see this red color even from long distances also. And not only that, here that is why here the first 3 colors which is of red, this orange or yellow and a green. These three we are using particularly in the traffic signals here, because they are having the maximum wavelengths are present when compared here to the remaining colors violet, green, yellow or orange or red. All these three we are having more wavelength is there. Having more wavelength means these waves can travel for longer distance here. So, which means even from long distance also we can see very clearly these colors. So, that is why here red is used there in traffic signals, yellow or orange and green, these three we are using that. Like this, depending on the color and depending on the velocity, we are having number of applications are there. And not only that, if you see as the violet color, if you are observing that having more deviation, so which means the refractive index for that is more when compared to the red color. Now, the same question if you want, they can ask like this also. When you are using a glass prism on a different colors of letters here, like you are taking in the colors red there, yellow there, green there, violet there. Of all these four colors, which appears to be more raised, that is one of the important applications of refraction there, which is apparent depth there. Having more and more apparent depth means nothing but having more deviation is present for the light rays here. So, if more apparent depth is there means more and more that is appears to be raised here. So, which means that here if you are keeping the glass slab on these different colors there, of which red color, yellow color and green color, if you take, the red color is having less wavelength, that is which is having less refractive index, that is. As it is having less refractive index, as the wavelength is more and velocity is more, for that it appears to be at less in depth, whereas in case of green color we are having more and more deviation is present. As more deviation is present, it appears to be at more height. Like this, depending on the color here, depending on the deviation here, the refraction effect changes for them. That refraction effect, because of due to that refraction effect only, all these colors are separated. This phenomenon only we call that as dispersion of light. So, one of the best examples of dispersion of light in our nature is about rainbow. In case of rainbow also the same phenomenon takes place, where we have dispersion of light takes place. Now, we will see the refraction through refraction through water droplets here. When the white light is passed through these water droplets, which is about our rainbow, a natural one we are taking, a natural dispersion phenomenon, which is about the formation of rainbow we are taking. So, rainbow is almost like the case of glass prism we have. When the light ray is going from one medium to another medium, which is a polychromatic light, if you are taking like white light, then after refraction the colors are splitting here. That color splitting only we call that phenomenon only we call that as a dispersion of light. Now, we are seeing this dispersion of light through water droplets here, which is about the case of rainbow we are taking. Actually, when you are having a series of water droplets are falling down during the rain, then what happens there is this white light, when incident on any of the water droplet here, whenever it enter inside, actually this dispersion phenomenon like the glass prism, it takes place, of which here we are having after the refraction inside that water droplet, here we are having down violet is coming up, red color is coming up there. But because of due to having more refractive index here, then what happens there is it takes a total internal reflection takes place. As due to the total internal reflection takes place, now the light ray is now coming back into the same denser medium, that is. Okay. So, that is why if you observe, when in case of this rainbow, if you see, as that is because of total internal reflection here, the light rays which are coming outside, first it is of red color, it will come out there, and after that we are having violet is coming there. Okay. Of which for the case of rainbow, down color we are having a red color is there, up color we are having a violet is present. Depending on the case, we are having this angle of vision we are having. So, we are having the different range of colors we are getting. Most of the cases, these colors we can see from 40 degrees angle to 42 degrees angle, that is, which means the angle between the color you are getting out and the angle of incidence on that water there. Here this range, it is about 40 degrees to 42 degrees, that is. It is ranging from 40 to 42 degrees, that is. For example, different colors if you are getting, down we are having red color, final we are having violet color is there. This range, it is around 40 to 42 degrees we have. Okay. like this 42 degrees. Okay. So, in case of rainbow here, that water droplet is acting like a denser medium, and when the white light, which is a polychromatic light, when incident on that water droplet, what happens there is a refraction takes place, of which here, as it is of denser medium, due to that second refraction here, as the refractive index value is more, and here the critical angle takes place here, as the angle of incidence is more than critical angle, here the total internal reflection phenomenon takes place. So, that what happens there is, now the light rays are coming outside, and when they are coming outside here, the red color is now coming down and violet color, all reverse we are having that. Red color is now coming down and violet color appears to be up here. So, in this case, the angle of the vision you have to take about 42 degrees if you manage. We can see the complete size of the rainbow here, the complete all 7 colors that is. Okay. And not only that, as the surface of the refraction takes place is of curved surface. So, that is why this rainbow is also formed like a circular surface, that is, that appears to be like a circular, that is, because the light rays which incident inside that, we are having a curved surface is present, as that is curved. So, that is why here the formed rainbow is also curved in surface we have. So, that is also coming like a concentric circles we have. We are having a concentric circles are formed. Okay, like this concentric circles you will get. Okay. So, these concentric circles, as we are seeing the angle of the vision there, which is of 60 degrees we have, so that we can see only half of that only we can see. So, that we are having like this only it appears, only a half semicircle only we can see at an angle 60 degrees, that is when you are seeing. Okay. That is of 40 degrees if you see, of which that 40 to 42 range we are having from red to violet colors we have. So, that is why it appears to be like a semicircular arc, this artificial rainbow. Okay. So, like this natural phenomenon of dispersion takes place around us is like rainbow we have. Next one, we are having questions coming on scattering of light. Scattering of light. The phenomenon of scattering of light is whenever these light waves, when incident on the molecules which are present in the atmosphere here, when the light incident on the molecules of the atmosphere like dust particles or air particles or some other particles if you take, then what happens there is, those particles or the molecules, they are observing this light and they are reflecting back, they are giving back here with different wavelengths. This phenomenon only we call that as scattering of light. Okay. So, see that phenomenon there, when the light ray incident on the particles which are present, on the molecules which are present in the atmosphere, those molecules absorb this energy and they are giving back that energy, which is re-emitting back the energy or re-emission with different wavelengths. This re-emission of the wavelengths in different wavelengths, re-emission of light in different wavelengths, that only we call that as scattering of light, that is, which is given by Raman. This is also called as Raman effect. But remember, because of due to this having a different molecules are present in the atmosphere, the color of the sky is gradually changes here. Actually, the color of the sky is because of due to scattering of the light. Most of the cases in our atmosphere, as we are having the nitrogen molecules are present, as we are having huge amount of nitrogen molecules are present there, then what happens there is, these N2 or oxygen molecules which are of having the observing the energy here, which is the light energy. After observing that energy, they are re-emitting back energy in different wavelengths. As depending on the size of the molecule, we are taking the nitrogen size. The size of the molecules varies just like our blue color light wavelength. It matches with the blue color wavelength. So, that is why the emitted color light rays actually depending on the size of the molecules here, as it is just like having the wavelength of the blue color. So, that is why it appears to be the light as blue in color, that is. So, that is why the sky appears to be like blue in color. So, always this scattering of light depends upon the molecule which is observing the energy here, depending on its size. If the size is different, then the scattered color light is also will be different. So, that is why if you observe here, as it is general cases, we are seeing the sun appears, the blue color, the sky appears to be like blue color because of due to having more number of nitrogen molecules. In the same way, if you are taking for the case of water, for example, during hot summer days, what happens there is we are having more amount of water vapor is present. As the water vapor, which is a H2O molecules, more are present in the atmosphere, then what happens there is here we are having the size of the molecule varies here, having more wavelength we have. Okay, having more wavelength means here what happens there is then it can reflect more, it can give more number of light rays here. That scattering color will be having the combination of all the colors we have. So that's why here in this case, if the scattering of molecules is because of due to that water molecules, which are the vapor molecules here, then what happens there is the sky appears to be like white in color. So that's why most of the cases generally we will see that the sky has a blue color because of scattering molecules or nitrogen molecules are more in number. Whereas when come to the case of hot summer days in the afternoon, as in the atmosphere the vapor molecules are more and more are present there. So that what happens there is here it appears to be like a white in color. Okay, like this, depending on the size of the molecule you are taking, the sky or the sky color is also gradually changing here. So that's why if you observe even that in the evening time and the morning time, if you observe these light rays, actually they have to travel from the long distances here, means more chances of getting scattered and scattered here. So that's why during the case of during the time of a sunrise and sunset, as the light rays are traveling for longer distance in the atmosphere and we are having more number of molecules are present, more and more number of times scattering takes place, so that the wavelength is also more we have, finally we are getting that appears to be like red in color. So that's why during sunrise time and sunset time, if you see the color of the sun is also appears to be like red in color, that is because of due to scattering of the light. So this mainly the scattering of the light depends on with what intensity that light ray is coming onto the molecule, and it also depends on the size of the molecule here. If you are changing the size of the molecule, of which taking like nitrogen you can take, water molecules you can take, or even for the case of longer and shorter distance you can take, depending on that only here we are having different colors are coming. So when you are taking the case of nitrogen, we are getting a blue color sky, it appears to be like. When you are taking for the case of water, which is having the size is bigger, there it is having more number of wavelengths are coming out, of which we are having a white in color we have. And whereas during in the evening time, so during a sunset time or in the morning sunrise time here, we will see that as the wavelength of the light rays are traveling for longer distance, we are having a maximum wavelength is present for them. So that's why it appears to be like a red in color. But remember, all this scattering of light takes place if you are having some molecules are present in the atmosphere. If you are not inside any of the atmosphere, so that what happens there is the color of the sky does not appear in any of the color that is. Best example you can take, if you are standing on the surface of the moon, of which we do not have any atmosphere is present on that surface. So that what happens there is the color of the sky appears to be black in color. If you are in any of the planet you can take, or in the space you can take, or even on the surface of the moon. Okay. So the color of that is decided by the scattered particle here. Depending on the size of the particle you are taking, this scattering of light depends.